Okay, so welcome to Mathstoria, and let's have this topic, the intermediate value theorem. Then we have this problem. So verify that the intermediate value theorem applies to the given function f of x equals x squared plus 5x minus 6 on the interval -2 and +3. Then find the value or the values of c such that f of c is equal to -10. So since the given function is a polynomial, not a rational, then it is continuous on negative infinity and positive infinity. Since continuous on negative infinity and positive infinity, so therefore it is also continuous on -2 and +3. Then solve for f of -2 from this given function, and x is -2. So we have -2 squared plus 5 times -2, then minus 6. Then -2 squared, this one is +4. 5 times -2, that's -10, then minus 6. Then simplify, so 4 minus 10, that's -6. And -6 minus 6, this one is -12. So f of -2 is -12. And for f of 3, so the same function. So we have 3 squared plus 5 times 3, then minus 6. Then 3 squared, this one is 9, plus 5 times 3, this one is 15, then minus 6. Then 9 plus 15, that's 24, and 24 minus 6, that's positive 18. So observe that f of -2 is not equal to f of positive 3 because f of -2 is -12 and f of 3 is positive 18. So therefore, this intermediate value theorem holds, and to find the value or the values of c between -12 and positive 18, and f of c must be equal to -10. So to solve now for c from f of c, so this becomes c squared plus 5c minus 6. Then since f of c is -10, so we have now c squared plus 5c minus 6 equals -10. Then simplify, so we have c squared plus 5c minus 6. So transpose this -10. This becomes positive 10, then equals 0. Then we have c squared plus 5c, -6 plus 10. This one is positive 4 equals 0. Then since this one a quadratic equation, so we can solve this one using this factoring. So we have these factors of c squared, that's c times c, factors of 4, so we can have 4 times 1 and all positive, then equals 0. Then to solve for c, so c plus 4 equals 0, so therefore c is -4. And the other one, c plus 1 equals 0, so c is -1. Since the value or the values for c is between -12 and 18, and since c equals -4 is between -12 and positive 18, and also this c -1 between -12 and 18. So therefore, since the conditions of the theorem are satisfied, we are sure there exists a number c equals -4 and c equals -1, between negative 12 and positive 18 such that f of c is equal to negative 10. So to check, so if c is negative 4, so from this equation, so we have negative 4 squared plus 5 times negative 4, then minus 6. So this negative 4 squared, that's positive 16, and 5 times negative 4, negative 20, then minus 6. So we have 16 minus 20, that's negative 4. Negative 4 minus 6, that's negative 10. So f of c is negative 10 if c is equal to negative 4. Then the other one, if c is negative 1, so we have negative 1 squared plus 5 times negative 1, then minus 6. So negative 1 squared is 1, 5 times negative 1, that's negative 5, then negative 6. So 1 minus 5, that's negative 4, and negative 4 minus 6, that's negative 10. So f of c is negative 10 if c is equal to negative 1. So the values for c, negative 4 and negative 1.